got your dotted versus solid, your test points, is it true or false? And then, is it possible to quick graph? Sometimes it is. Okay. So what we're going to do is kind of walk through a couple of ideas. When we get into the shading, when we get into a shading setup with these types of things, we are going to have an overlapped shaded area region. Maybe. Maybe not. It could be going some other directions. We could be shading a triangle when the lines intersect one another. There are many different things that we're going to be looking at. But this topic of shading these inequalities, it blends us to what we're doing for the rest of the week. I put up on the board already, today we're doing the graphing the systems of inequalities. Tomorrow we start constraints, maximum and minimizing functions. And then after that, we'll get into the word problems for the next 2-3 days. So it's very possible that we might be in section 3.4 for 4 days. Okay, it's a very difficult subject, and there's a lot of word problems that are built into it. But it all bases on whether or not we know how to graph and shade. So real quick, if I'm looking at 3x minus y is less than or equal to 2, and 2x plus y is less than or equal to 2 as well. Way that we've been graphing these in the past. Oh yeah, I was going to say, if you happen to have two different colors, you know, a pen and a pencil, sometimes it is helpful for shaded stuff because you can start to see that some of the overlaps a little bit cleaner. If you don't, it's not the end of the world. I know you've got a box of 64 back there, so you can have more than 2 colors if you really get fancy. My parents never bought me the 64 box of crayons. They only got 24. I held a grudge until I turned 30 and my parents bought me a box of crayons. I'm not lying.
What?
Seriously, I got that. Yeah. Anyway. So I'm just going to do this the old-fashioned way and go negative y less or equal to negative 3x plus 2. Y is greater than or equal to 3x minus 2. Everybody okay with that first graph? I just solved for y. I used the rule of changing my inequality symbol because I divided it out by the negative. Now from here, I'm going to use my blue pen to mark it and go. Will this be a solid or a dotted line for that one? It's going to be solid. So I started my negative 2 and I walked my slope of 3. And then I connect my dots with my solid line. Okay. So far, so good? What's the next step for graphing of inequalities? Shade them. Does this graph go through the origin? No. Nope. Is 0 minus 0 smaller than 2? I went back to the original equation. Is 0 minus 0 smaller than 2? Yeah, it's true. So I shade up here. Okay? Now I do the exact same thing with the other equation. I'm just going to switch colors. Black. And I get y is less than or equal to negative 2x plus 2. Just move the 2 over. So now with that graph, I start at positive 2 for my y-intercept, and I walk my slope of negative 2. Down to your right 1. You can, and I was going to get to that next. You could have quick graphed the other one as well. Is that a solid or a dotted line? Oh, that's solid. Does that go through the origin? Okay. 0 plus 0, is that bigger than 2? No, it's smaller than 2, so it's a true statement. So this one is shaded in here. Now, does everybody see where the overlap occurs? Your overlap occurs within this boundary. And that's what we're looking to find. Find the overlap. What this means is that if I pick any ordered pair that's in that double shaded region, one that's shaded blue and that's shaded black, that ordered pair would be a solution set to both inequalities. That's what that tells us.
Inside the?
Yeah. If you pick
inside the crossed out area?
exactly. At any point any point that I put in here, in this double shaded region area, would be a solution to both of them. So if I picked -10 and 0, it would make this a true statement for both inequalities.
But that's the false area.
Excuse me. No, it's a true area. Remember, we always cover the
yeah,
true.
that's the true. Okay.
Yeah, we always cover the true. So any point that's in this double shaded region would be a solution to both of the inequalities. All right, so that's kind of what we wind up doing. Yes, sir.
Now, when shading, would we shade just the part that makes both equations true, or would we shade the part that makes one true and then shade the part that makes the other true?
Did you see how when I do my shading, if you have two colors, you're all right. Or if you lightly shade and then you can darker shade where they overlap. You know what I mean? So if you're going like this direction with all of your shading and then do a basket weave pattern where they cross through, when we do a couple of them, you'll start to see how it goes and what does it make it look better for you to do. Okay? And like you're saying, we could have done quick graphs here. We could have done quick graphs because it was in standard form. Cover and solve. Intercept of 2/3, intercept of -2, intercept of 2, intercept of 1. And we could have done that. Connect the dots, la 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 la. Okay. Let's try another one. That's a big graph. Let's move this over. What do we got? Y is greater than or equal to -3x minus 1. And the other one is y is less than x plus 2. I don't need to worry about moving anything around. It's already left in good old thing. It's already left in slope-intercept form. Go to your y-intercept and walk your slope. -1, slope of -3. Solid or dotted? Solid. And then use your test point. Is 0 larger than -1? Everybody okay with me saying that? 0 is larger than -1? So that means I'm true going this way. Then I do the other graph. X plus 2. Start at +2. And +1 slope. That was a dotted line, so I got in the habit of kind of filling up the whole graph with all those dots anyway, so I can just do this. And then is 0 smaller than 2? Yeah, so that one gets shaded below it. So now once you start to see, this is your overlap area. So as I stated earlier, any point that you pick, any point you, I just screwed all that up. Any point you pick that's in this double shaded region, way out here, would be a true statement for both ordered pair or both inequalities. Okay? We're just trying to graphically create a bounded area. All right? You see now how your overlap, your shades kind of, it's pretty easy to see the overlap. Not terrible? Okay. There's some constraints like okay. You don't like it? There's 3 of them. There's 3 of them. X is greater than or equal to 0. Y is greater than or equal to 0. 4x plus 3y is less than or equal to 24. Now, where is this going to get us? Just this statement. First quadrant. Does everybody agree? X is greater than 0, y is greater than 0. Right away, I know that this is all first quadrant. These are all first quadrant. Everything's going to be first quadrant so far. Okay? Now, I'm not going to graph to a 24 y-intercept, am I? Why not? Quick graph. What's your x-intercept? Cover and solve. What's your y-intercept? Connect them, and I know it's going to be in this triangle area. What I've done here is we've created a bounded area bounded by a triangle.
Oh, wait, what did you do? Like triangle?
What I did to make the triangle, and it's sometimes this is easier to see without the grid. Let me show you. Once again, we agree that the first statement being x is greater than or equal to 0, y is greater than or equal to 0. We all agree that's the first quadrant problem, right? So if I didn't have the grid in front of me, I would do this. And I know for the x values being greater than 0 is everything going that way. And for the y values being greater than 0 is everything going that way. Just for a rough idea. After that, I did the intercepts. 6 for the x-intercept, 8 for the other. Here's 6, and here's 8. And then the only thing I had to figure out is where to shade it. Does that graph go through the origin? No. What's 0 plus 0? 0. Is 0 smaller than 24? I think so. That's why I was shading in here. So this is where we get this shaded region. Okay. What we're able to do now from graphing out these shaded regions is that you could actually find the intercepts or the endpoints of a shape like this. You can find the endpoints of the triangle. I know it's at 6, 0, 0, 8, and then what's this one here? 0, 0. All right, for $1 million, what's the length of the hypotenuse?
8 or 10 units long.
10.
So how are you going to
Triple. 6, 8, 10.
like shit?
You know, I'll give you an IOU. How's that? All right. Let's try another one. Where's the pen? Oh, there it is. Do you have some credits today?
For speech.
What's your speech on colored in the lines? Or stay within the lines? Drawing pictures of dinosaurs? X is greater than 0, so I know it's everything going this way. bigger than -1. Yes. And then start at +3. See how it's pretty easy to get lost in your shades if you're not careful? And then is 0 bigger than 3? It's not, so it just winds up being more out this way. So really the only overlap area is this little boundary up here. That's really the little itty bitty spot up at the top there. Everybody see that? It's tough to see on the large grid. So you get that little top spot. Like I said, it is possible that you could have a shaded region that there is no overlap as well. I have seen problems like that where you wind up with, a line going this way. You might have parallel lines with shading going on both sides. But I have seen problems like that as well. You're just looking at an overlap shade. Saving graph paper one piece at a time. Let's see.
Wait, since x could equal 0, wouldn't it be like pretty much all from the y is greater than x2 minus 1? Wouldn't everything from that line backwards towards 0 would be, wouldn't it all be?
Yeah, it is. But if you're looking at it, the values that are both in that shaded region area wound up, once the purple hit the black, then that was covered here, but you were bounded out by x equaling 0. So you just have this little region up in here, and obviously continues up. Okay. Sometimes it's tough to see if it's a very small spot on the graph paper. Oh, just open it, okay. All right, try this one with a quick graph. No graph paper. I don't know, you guys have much graph paper, don't you? All right, well, whatever. I gave you graph paper, and sometimes it's